So, everyone can hear me?
Yes.
This is going to be rambling, as always. I want to thank my sponsor. I work for Dropbox. They flew me out here. Nobody asked any questions. What are you going to do there? I'm just here for you all, not for Dropbox. But I do want to mention that they were very helpful. A party that was not so helpful was the Canadian immigration. No, seriously, until Friday, 1 p.m., I did not know whether I was going to be able to make it or not. And we had a whole backup plan where we would switch with another speaker, and I would give the talk over Skype. That's how bad it was. And fortunately, the Dutch government came through at an amazing speed for bureaucracies, with the necessary paperwork that could, in theory, convince the Canadians to let me in. Then there was a little problem with the Dutch Post, which is privatized and took 6 days to deliver the mail from point A to point B in the Netherlands, both large cities, not too far from each other. But it all came out all right, thanks to these two organizers who sort of gave me moral support, worked on Plan B, Plan C, stress tested the video conferencing, everything. So, and in the end, I'm here, so who cares? So the topic of my little talk is, well, it is a Python retrospective. So why a Python 3 retrospective? Why is there a Python 3 retrospective? Why was Python 3 such a big deal? So I have to explain what goes into making a language better. The language is like the sort of the most fundamental part of the software that together builds an application, all applications. And so a language is typically the thing that changes the slowest. And the change in a language has to be considered incredibly carefully, because you don't want the next sort of version of an app to break because you change the language. That's a general principle. On the other hand, users always want new features. Nobody wants their code to break, but they always want everyone else's code to break by adding the keyword that they want. So the compatibility is a terrible, terrible blessing. As I also mentioned in one of the bullets here on the slide, I compare it to building sort of a better freeway. And you may not like freeways, but they're sort of a fact of life, and sometimes a freeway needs to be expanded or improved, and that usually means that first there's going to be years of traffic backup. But eventually the cars can actually go where they want to go. So that's my sort of sadly American metaphor for evolving a programming language. So the general idea is that you take features that you no longer like and you say, we're going to deprecate this. We're going to sort of slowly start telling users that this is no longer a feature that has much future in it, and point them to sort of the replacement, the better way of doing something. Let me make up an example. There's a lot of places in your code where you have try finally blocks to, say, close a file. Long ago, around Python 2.4, I believe, we introduced a with statement and the notion of context managers that let you write this in a much more elegant way. So you don't have try, open the file, do something with the file, finally close the file. It's important to close your files, and when it's not a file, maybe it's a database transaction that you want to commit. Now you can write with, open the file as some variable, and then in the body of the with block, you do whatever you need to do, and Python generates code that will also make sure that the file is closed. That's an example of not literally a deprecated feature, but a better way of doing things. And that happens all the time. Every time a new version of Python comes out, and new what we call feature release, 2.4, 2.5, 2.6, 2.7, 3.6, 3.7 is coming out soon. Every time we have new features and some old features get deprecated. We don't just suddenly delete features unless we're very sure that it's a very dark corner that nobody has any business doing, but we're incredibly conservative there. But sooner or later, you end up with some features that you no longer like and where there's not an easy way forward. Even though we try to design features in a way that is sort of future compatible, allow changes, leave space in your API for new developments, new needs from users. Users are always going to do things with your language or with an API that you didn't think of when you designed it. So you always have to leave space for improvements. You also always have to accept the possibility that you made a mistake in the design, and those are really difficult to get rid of sometimes. There are some fundamental things in the language that just, they are the way they are, and there's no way that they'll ever change. And you can sort of talk yourself into accepting that, oh, actually, this is a cool feature, but sometimes it's also a pain in the ass. And I'm not going to give specific examples, but this is the general process for evolving a language. What do we get next? So Python 2, and we're talking about the early 2000s here, to 2004, I think. I found the first reference to something called Python 3000. People were well aware that certain features in the language were unpleasant and sort of bug factories. Standard traps that every new user sort of has to be bitten by once, and then they've learned never to do that particular thing again, like mutable default argument. This is a fairly random selection of words. I didn't find the original Python words paper by, I think it was Andrew, blanking out on the name. Andrew Kirtley, absolutely. He went around to conferences sort of warning people of these certain words and also sort of implicitly asking that the core developers do something about some of them. And we try to, but some things are easier to fix using the sort of evolve and deprecate approach than others. And in particular with the Unicode mess, we were just completely stumped. Because the way Unicode is done in Python 2, you have these strings and you don't know whether they're meant to be text or binary data. And when you treat them as text, everything goes hunky-dory until someone puts accented characters in them, and then suddenly, maybe your program will crash. That was a rather unpleasant experience. And when we put Unicode in, we were so hopeful because we knew that Unicode was somehow going to be the future instead of all the different other encodings that existed. But we didn't know enough about how Unicode would really be used. And we tried to put in really strong backwards compatibility. And it turned out that the compatibility we built in became at the same time a feature and a sort of a terrible wart. So what could we do? And for the longest time we were just evolving the language in a compatible way, but finally we realized this and a few other things we just could not sort of fix without backwards incompatibility. And so after a lot of hemming and hawing, this was not an overnight decision. A lot of discussion went into this, a lot of debate, a lot of thought. We actually chose to break backwards compatibility. And this is where Python 3 was born. So we realized that this was going to be a very tricky project. So we tried to engage in some risk management practices. Like we were aware of projects. I think Perl 6 was the worst nightmare, where a complete new design was being made and everything that could possibly improved in the language was being improved. And as a result, there was zero compatibility, and also it was really difficult to get the community to start adopting the new thing. We didn't want to sort of fall in the trap of second system syndrome. So we decided to be relatively conservative in the way we evolved the language. We wanted people to look at Python 3 and just say, yeah, that's Python, of course. It doesn't look any different from the Python I've been coding in for years. And we were successful at that. We decided to involve the community. We created a PEP process, a sort of a new version of the PEP process specifically for Python 3, and all those PEPs are still on the PEP registry with numbers starting with 3000. In fact, PEP 3000 itself, there was an original PEP 3000 that was created somewhere in the middle of 2004. And actually, the first version of Python 3 that was released came out nearly 10 years ago. This year, 2018, we can celebrate 10 years of Python 3. We were very clear that we didn't want to start creating a whole new interpreter. We had heard about the sort of failures of Netscape to reinvent their browser from scratch. There's a very influential blog post by Jamie Zawinski and a sort of a follow-up by, sorry, I forget the guy's name. Joel Spolsky, yes. If you haven't read those blog posts, they're definitely worth reading. So we wanted to sort of do gradual change, but at the same time, we did introduce some backward incompatibilities like we had never done before. The biggest one really was what we did with Unicode. And we were planning the end of life for Python 2, which at the time when we were working on Python 3 in around 2006 to 2008, we thought that by, 2010, 2012, Python 2 would probably reach its end of life. So, What went wrong? And looking back, really, I believe what went wrong was that we just weren't aware how many people were using Python and were really depending on it, and had written large proprietary code bases, or at least sort of code bases that weren't widely shared, but that were important to them, where they were using every trick in the book that was undocumented but happened to work in Python 2. We specifically didn't realize that by then a whole ecosystem had sprung up of third-party packages. Obviously, we knew there were third-party packages. There was the cheese shop, as it was called at the time, I believe. It's now PyPI, because someone didn't like the Monty Python reference. But we didn't realize that the way most people and a lot of companies build software have dependencies on 100 different third-party modules, 100 third-party packages, and not just things like Django and NumPy, but like lots of tiny little modules that solve one little problem in the corner of decoding dates in JSON, or you name it. And these packages all have reasons to exist, and they solve one particular problem once and well, but most of them were also totally not compatible with Python 3 as we designed it. We had thought, of course, about how are users going to take their Python 2 code and transform it into Python 3 code. I wrote a whole In fact, I reinvented a parser generator that I had sort of created in C in 1990 to build Python itself, to parse Python itself. I re-implemented the whole thing in Python and then built a library on top of that, still known as lib223, that can do source-to-source transformations on Python source code and do things like rename functions, insert arguments, remove arguments, based on a sort of pattern search in the source tree, while preserving the layout, comments, indentation, exactly detailed white space everywhere in the source code, except for the places that you were actually modifying. And yet this was not enough to actually transform Python 2 code into Python 3 code, because the one bit of information that that tool didn't have was what are the runtime types of these variables. And if you don't know whether a particular variable is a dict or not, you don't know for sure whether when you see a call to a .iterKeys method, that you can actually safely translate that into a keys method. Tons of examples. That sort of, for certain things, the tool was great, like turning print statements into print functions, bingo. Lots of other things, between 20 and 80% success. Unicode-related stuff, 0% effective. So we knew that this tool was far from perfect, so we designed a whole workflow around it. We just didn't realize how people would really sort of end up using that workflow, where they were spending all their time waiting for that tool to transform the source code, because it was very thorough but also not all that fast. What we intentionally didn't do, but what I still regret, is we said there will be no way at runtime to combine Python 2 and Python 3 code in the same process, in the same Python interpreter. It's either all Python 2 or it's all Python 3. If you want to talk to each other, write data to a file or to a pipe or use RPC or something. That sadly made it so that everyone had to really convert all their code and all their dependencies, like all the third-party packages they were using, to Python 3 code before they would actually be able to run that code in Python 3 and benefit from any of the Python 3 features. So this sort of, all this held people back, and it held back library developers probably the most, because the library developers had this, a typical Django release, for example, publishes a whole range of Python versions that it's compatible with. It's compatible with Python 2.4, 2.5, 2.6, and 2.7, and also 3.2, for example. That's incredibly difficult to do. And so all the original vision of how people would do these kind of things did not work out as expected. We also made a few sort of low-level mistakes that we eventually fixed. Like, it turned out that there was a better process for turning Python 2 code in Python 3 code, which is to first use a stepping stone called straddling code, which is Python that is source code compatible with both Python 2 and Python 3. And originally, when we were sort of talking about what the conversion process should be, we thought that the intersection of Python 2 and Python 3 would be so small as to be unusable. It turns out that it's actually not so bad, and support libraries came up to sort of bridge the gaps in both directions, the most famous of which is 6. There were also small tweaks we ended up making to the language that really helped. Like, In straddling code, you often have to have Unicode string literals. And in Python 2, the only way to create those reliably is putting a U in front of it. Python 3, on the other hand, does not have a difference between Unicode and other string literals. It has string literals. It has, in fact, a string object type, which is always Unicode. And it has a byte type, I think, which is completely incompatible. So finally, in Python 3.4, I believe, we relented and we made the set of straddling code suddenly much bigger by allowing that useless U in front of string literals in Python 3. We also didn't finish all projects that we had set out to finish. The standard library was not done all that well. So the standard library is really some of it is really nicely Python 3 style, and some of it is really more like, oh, that's clearly still Python 2 code. So, lots of things went right, fortunately. Python is still incredibly successful, and it's still getting better. Python 3 has finally sort of climbed out of the valley and is sort of driving all new Python adoption and new Python usage. And the people who are still struggling with Python 2 code bases, like I have to admit myself at Dropbox. Dropbox is a huge Python 2 shop. I got them to move to Python 2.7 pretty quickly when I started there 5 years ago, but we're only now, this year, are we seriously starting the Python 3 conversion. Also very important, despite all the sort of disagreement, the community never split. There has never been like people who walked away and said, we're only going to do Python 2. Well, maybe there was one guy, but in general, that's sort of, we're all here, and I can tell here who is Python 2 or who is a Python 3 user. And it doesn't matter, because most of all the stuff is still, even if you're using Python 2, you can still read Python 3 code and vice versa. So the community also sort of picked up where the core devs dropped the ball with the conversion process. And there are much better ways to convert these days than what we had originally envisioned. And third-party packages have all been porting. I mean, I remember being incredibly happy when Django announced that they were going to officially target Python 3 for one of their releases. And it took them several releases to have useful Python 3 support, but just the commitment was great. The same for the NumPy and SciPy world. So yeah, I just had to brag. This red line is Python popularity according to Stack Overflow. So you can think of that what you want. And the other languages there are PHP and C# and Java and C++ in no particular order. Yeah, I do want to sort of brag a little bit more about all the good stuff we have in Python 3, but I have very little time left. And I'm going to try to rush through this. Performance is actually better now. That took a long time. Python 3.2 was not faster than 2.7. Python 3.6 is a lot faster. We fixed the Unicode problem. We may not have fixed all of it, but really Unicode is so much better than it was before. A whole bunch of other stuff that I'm going to... F-strings. F-strings are amazing. Type annotations, of course. The coolest little feature that... this got amazing response on Twitter. Dictionaries preserve order. If you write a dictionary and then you print it back, it will come back in the order that you wrote it. This is very handy for testing and stuff. And it's now an official part of the language, not just an accidental behavior of one implementation. The amazing thing is that when that patch landed, dictionaries did not become slower. There's also something called data classes, UTF-8 mode. I'll skip that. I'll also skip the list of ho-hum features, like the numeric tower never really got any use. Unicode is still hard, yes, file system encodings. Yeah, if you're on Python 2, what to do. Don't despair. You can do a little bit of research and find all sorts of useful talks and books and tools to help. But you got to start now, because in 2 years, it's end of life party. And the person who will be partying hardest is Benjamin Peterson, because he has been the Python 2.7 release manager since, I don't know, probably since 2012 or so. Yeah, straddling mode, I already mentioned that. Try not to change too much at once. So port your app or redesign it. Don't port it and redesign it, because then you might as well just rewrite it from scratch. What will the future bring? Python 3.7. It will be awesome. Yes, we've learned a lot from the Python 3 transition, and eventually there will be a Python 4. But the way we manage the transition will be very, very different, and we will not be stuck with Python 3 and Python 4 in parallel for a decade. And also flying cars. Yeah, I have a postscript, which is that there will not be a Python 2.8 release, which should be clear by now. And I've made a commitment to try and meet 25 new people each day. And the way I calculated that number was, someone tweeted that, I think the same guy who invented came up with the Pac-Man rule. He said, you should try to meet as many new people as the number of years you've been coming to Python conferences. So there, the first Python workshop was in 1994. So I'd say about 25. So, I mean, when you see me, say hi. Don't be shy. Thanks, everyone.